There were a couple other funny incidents, but we won't get those on recording. Tuna can do some stuff to your digestive tract. Sometimes that happens in the middle of the computer lab. That's all I'm saying. Didn't have what?
Didn't have Keynote open?
I think I rebooted.
You rebooted?
I think so.
Yeah.
Oh no, then I only rebooted in here. Oh, I think there was a Keynote update. I maybe close it to do the update.
Those are so dumb.
Well, yeah, and then 2/3 of the time it says, okay, this is offline, so your slides aren't going to work. All right, we're still writing our flippy dealy. Where do we leave off? I'm using code, right?
Yeah.
All right, so we wrote the send. So there's a back and forth. We're assuming it's going to be Cambria. This is, we're in the client driver. So we're going to create our streams. The client's going to keep writing stuff to the server, but this is after they have a little bit of back and forth. So this is our made up protocol here, where we read something in from the server, write out the question, read in the answer, write it back out. And then if our answer was send, then we're going to go into the send mode, because presumably the server, which is going to be in our torrent thread, if he received an answer of send, now he's expecting to receive a file from the client, because the client said, I'm going to be in send mode. So he'll create a data input stream to read from the client socket and just start reading stuff in until he's out of stuff. And I think what we did last time is we just had it printing the bytes, right? And we did that in core. Yeah, right now we have process byte, and this guy is going to write it out to all the data output streams, the people who are going to be receiving. So if we are a receiver, so we wrote this at the very end. We haven't actually broadcast bytes yet, but we set this up inside of our singleton to take in an individual byte and send that one byte to every data output stream that we have. And we have the ability to add data output streams to our list of, or array list of data output streams called the client DOS. All right. That's how you pronounce it.
Yeah.
It is. Okay. So when somebody wants to receive, the first thing they need to do on the thread side, if we're going to be a receiver, we're going to say we're going to be, the answer is receive, we're going to be, yeah, sending a file to the client. So if the client's in receive mode, the server will be sending a file to that client. So we'll go ahead and add the output stream, the data output stream for this client to core. All right, so now this guy then needs to, I think this is where we left it at the end of class. This guy now needs to basically sit there and wait for the other side to finish, right? So we need to look at what does he do if all he's done is look at his data output stream. And we'll get to that. We'll see what the behavior of this is. I mean, worst case is we can just put a busy wait loop in here or something like that. Like a while true, do nothing, and then somehow break out later on. But I suspect that after we add our data output stream, even if this guy finishes the socket, I think the question I asked at the end of class is, will that data output stream that was built around the socket, will that still exist even if this thread dies? And I think my guess is no, it won't, since the socket, this client socket, is a local variable of this instance of our torrent thread. So when that socket comes in, it's a local variable and it's going to live and die as long as its thread's alive. So if after this line down here, if the thread dies after this line, that socket's going to get reclaimed as well. The saving grace might be, since core has a pointer to that data output stream inside of its array list of data output streams, that because there's still a pointer count of something greater than 0 related to that socket, that the socket won't actually get picked up by automatic garbage collection. That's the hope, that you'll have a dead thread, but you'll have a living data output stream. I suspect that's not going to be the way it works, but that's a possible way that it's going to work. All right, so let's write the client side of this. So in the client, if we're in receive mode, the idea is we're just going to keep picking up bytes. We're going to be reading bytes. So really our code is going to look a lot like what the send mode looked like here on the server. So we're going to have our, I'll just copy this guy here. Actually, it was only a couple lines. So like, why waste our time? Oh, well, I'm not going to do it. Receive mode. All right, do I already have a data output stream? I do. So I have my DOS up here, data output stream. So we're just going to say while true. And we're going to throw this guy inside of a try catch. We're going to try to read bytes forever. And then take advantage of our catch system to bail. And we'll catch, what was it, EOF exception. Left eye is not working. 1 second. Nope, I'm just gonna have to go without. That's the way it goes. You never have that happen where just one of the eyes stops? Like it gets like super blurry. Like, I mean, I still get light and stuff. Yeah, but it was like, it was fine a second ago. This one's super clear today though. Top, no, I don't think so. I just have bad eyes. Do I not have my, I do have my EOF exception. Oh, he's still screaming because this guy throws another exception, right? I think he also throws an IO exception. I'm gonna do nothing with that either.
Scroll down. Like go in the window.
In the
Go
who?
up over the window.
Here?
Yep.
Oh,
And
then,
go in the window and scroll down.
oh, it's unreachable because of the while true. Oh, because I haven't written anything in here. It'll get fixed in a second. All right, so then we're going to read in a byte. So we'll say byte B is equal to data. Where am I at here? Chat server. Why was this guy reading in? Oh, this is the send. He's reading in bytes from his from the file. So in this case, I'm going to be reading in bytes. I want it from the data input stream. So I don't have a data input stream for this guy yet. So I'm going to try to create a data input stream. So we're going to say input called DIS client, something like that. This could be a new data input stream from this dot the client. Isn't it called the client? Or is this client? Oh, it's just called S. We're not inside of an object. Get input stream. All right, so we'll build our data input stream. Now, this data input stream is different than this data input stream. This data input stream was reading in stuff from our local file when we were sending contents of the Cambria.jpg over there. This data input stream is built around the input stream associated with our socket because we're going to be reading bytes from that socket that's being sent from the server. So we'll say disk client dot read byte. All right, so we'll read that byte, and then we're going to end up doing something with that byte. For right now, before we do anything else, let's just have it spit it to the screen before we do some file IO stuff. So we'll do a system.out.print b, followed by a space or something like that. When we catch end of file, we'll do a system.out.println file received, something like that. For this guy, we'll just do an e.print stack trace. All right, so we are relying on this end of file exception to occur when we try to read from here, and the and we fail when we read that byte because it was an end of file symbol. I'm thinking that's going to work on this side as opposed to that being something that's only based on file IO. If it's something only based on file IO, that's okay. We'll just have to come up with another thing we can send to notify this guy that something bad has happened. So let's see what the current behavior is. See if we get to the file received. All right, so right now we say we're in receive mode. What does the thread do if we're in receive mode? He's going to go through and he's not actually doing it yet. So we're going to add this to the DOS. If we're in the send mode, what we're doing, we're broadcasting. Okay, so we need to make sure we set up our receiver first so that he's already waiting. And then we send our, have our sender kick in. So that guy's listening. What do I have in here right now? Okay. So we'll go ahead and compile this guy. All right, so he's going to be the receive. We should see that a dude connected over there. So we just printed out sending a file to the client. Read byte is blocking. We're going to be on the send side here. It says finish sending file. This guy got a whole bunch of crap. I never saw a file finished though. He finished receiving the file on the server. So server got all the bytes. Server pushed all the bytes to the receiving client, but he never actually told the receiving client, you're done. So we need to have some way of killing off that receiving client. So how do I send a final byte? Let's see if we can flag an IO exception, if we can force an IO exception from the thread. Because on the client side, this dude is not getting tripped, which means that we're still sitting here blocking on our next read byte. He's trying to read, and we still see him sitting here. This last guy, not that guy, this guy. He's sitting here waiting to read that next byte. So that read byte's just blocking. All right, so we're gonna have to send him something that is a byte, but it's gotta be, I don't know, a byte that's not a real byte. So we have negative numbers here. I'm thinking if we're not gonna send him something, I think we wanna kill the socket. That means he'll lose his connection, but we're just gonna say that's okay for right now. So from the server side, this thread, when we are done receiving the file, that means we've already sent everything. Do I have access to my socket in here? That is it's called client socket. So I'm going to go ahead and just try this. Where's my done receiving file? We've already broadcast. Okay, so we're going to go ahead and do this dot client socket dot close. Let's just close the socket. I think that'll give us an IO exception on the other side. So it won't be an EOF exception, it'll be an IO exception. So I'll just move our file receive dealy flippy thing here to right here. I'll leave the print stack traces just so we can see what it looks like. I'll put it up here too, just in case we get one of those. I'd be interested to know what kind of thing came over the socket that was an EOF exception. End of file sounds, well, it is a file thing, right? The question is what does end of file mean? In old file systems, a file would actually have a special character that was the EOF character, which was a byte. So I guess I thought, well, maybe it would receive the EOF byte. And we might even be able to check for that, but it seems like it is blocking because the other guy's not sending bytes anymore. So we had the exception on the other side. So we're dead in the water. But hopefully if we break the socket when we're done sending, this guy will flip out because he can no longer read a byte because they just got hung up on. This dude will fire and he'll say files now received. That's what we're hoping goes down here. Everybody's disconnected. Well, that's an IO exception. That's fine. At least it says it's not, didn't say it's deprecated. Or is this like a snippet? Ah. I thought there was gonna be a Will Smith moment. Boom. Last time I listened to your crap. So this guy threw an exception, so we're actually still inside an EOF exception. This is actually going to be an IO exception. IOE. All right. So that guy's good. Start our server. We need to start our receiver first. He's going to be receive mode. Then we're going to start our sender. Finish sending the file. He received the file. Ugh. Still blocking. Oh no. So he's trying to read from a dead socket. I think we saw before we cannot close our data input stream, right? Or data output stream. What do I have? Well, I think that's what I'm doing. So when we're in receiving mode, as soon as we're done receiving, I'm closing that socket.
Oh.
Well, we might be able to go through and close the connecting guy's socket. Let's just try something here. So this is kind of showing that maybe the issue is that it is staying alive. So if we do we can just test that real quick. We'll say public, static, synchronized, void, remove receivers, something like that. Let's just say core dot the client, blah, 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 that remove all. Just like a clear. All right. So that should get rid of all those pointers, presumably killing off the sockets that they're attached to. See if that makes a difference. So what we need to do is inside this thread here. We can close the socket, but before we do that, we'll do remove receivers. So that should remove all the output streams from that. Then we close the socket. There should be nothing kind of holding that socket open because we have pointers in other places. All right, he's in receive mode. It's in send mode. Oh, still sitting there. Let's see if there is an EOF character. So I'm finding it difficult to trigger an IO exception on the client. See, the problem is if we're sending bytes, there's 256 unique bytes that could be sent over there. How do I know that the byte being sent isn't a byte that's already being, that isn't a legitimate byte? So we go through this big list here. These are all the possible bytes that are coming through, positive and negative numbers. It's not that the bytes are actually a negative, just I'm spitting them to the screen and it's treating them as being encoded in 2's complement. That's why some of them look negative. I don't know if, yeah, so I have some zeros here. I'm guessing that we don't actually have a null byte. The problem we're trying to solve is how do I get the server to broadcast to all the children some byte that makes this guy flip out and calls one of the exceptions. Let's see, I'm in the client here, right? Makes this guy. Makes this guy flip. Ay, ay, ay. Ninja. Makes that guy flip out and call one of these 2 exceptions. Because it's blocking on this line, and that's why, I mean, we've read all the bytes that we need to read, but now the client isn't dead. In fact, I suspect if we write this out to a file and we manually kill the client, we'll probably have our output. Yeah.
What if you just do like a timeout type thing? Where it doesn't receive anything?
We can, but then we'll have to make sure that's long enough to let us start our sender before, because we start the receiver first. And that receiver's waiting while I go and start the second client to do the sender.
Would you like 5 seconds?
Yeah, we can. It'll just be a race. So, I mean, potentially a doable solution is kill it off. I just wonder if there's something better we can do. Let's this. That is core broadcast. We're going to broadcast a byte. Java. Null byte.
We just have to use sequence of bits that.
Yeah, but then we just hope that that sequence doesn't exist in the file.
And make it like the exact same thing. Like 40 zeros.
Yeah, I mean, right. I mean, you're right. What are the chances? But it's greater than zero
Yeah.
that there could be 40 zero bits. So what he's suggesting is we kind of have like a secret code where I'm gonna send you like he said 40 bytes, the number 0 in bytes 40 times in a row. And if you happen to get 40 zeros in a row, you're pretty sure it's me letting you know things are done, as opposed to it just happened to read in 40 zeros and sends them in, because now we got to, so every blue moon will get a corrupt file or something like that. Yeah.
If you had two sequences, and as you're reading in the file, and so when you're sending the file from the server, you check to see if that sequence existed in
Sure.
the file, and then you.
But there's still a chance that both sequences could exist. I mean, you're not wrong. Chances are this would work. We would get away with it 99.9% of the time. But we want to pay attention to the fact that it's technically possible that the moons could align and your special bytes, might not. What if we just send null? Does null count as a byte? Primitive type. Will that make it freak out? I mean, I'm going to broadcast a null. See what it does with that. Yeah, that's all we need to do is get it to freak out. If it'll freak out, then mission accomplished. Cannot be converted to byte. No, it did freak out. What is a null byte? You could have a second thread reading text, and it would sit there and block until we send it a, all done string. And when he got the all done string, then he would kill off his brother thread. Say, okay, you're done reading. Stop trying to read. The mission's over. That would actually work. Oh, here's a poison byte. Let's see what this guy is. Originally dubbed as the Olaf Kirch. I'm guessing that's based on some historical thing. I don't think in Java it is. No, because once we have the bytes, it won't be a problem. So like, that's why I said if we were writing to a file right now, I suspect we could probably manually kill our client, and our file would be the copy. We've received all the bytes that make up the file. We just have stopped listening for the next byte. Yeah, I mean, we've seen them all appear on the screen, so things look okay. Let's do Java data input stream. Let's see if there's something in here that can get tripped up. Actually, let's look at output stream. We could try to close it, but I think we saw that that is deprecated. It doesn't look like it's deprecated. Let's do that. Instead of removing all of them, let's close it. So we can do that in core. Let's say for each data output stream, tell that guy to close. Why? Just in case it's a null value, right? I compile that. Seems like bad advice there. I'm still doing my broadcast null. Dump that. Oh, I don't think it's for each in Java. I think it's just for. Yeah, it's that guy. But it also said it didn't like the close. Oh, it's just an exception. We can work with exceptions. All right, so we're going to go through, we're going to close all of our data output streams. Then we'll clear our data output streams. Make sure we're doing that from within our thread. We're going to say remove receivers. That'll close them all. Then clear the pointers to them, which I don't think we need to do, but we should, if we're done using them, we should clear it. We're closing the socket. I'm not sure if we need to do that, but we're doing it. This guy should compile now. Server. Don't think we made any changes over there. This is the receiver. This is our sender. All right, it did get end of file. Woot. All right, so then all we need to do is come back over to client. Put this guy back where we originally had him. Yeah, we definitely are getting in there. We'll run it just for. All right, and so he got his file. So now we just need to do the last step of outputting it to a local copy file thingy majiggy instead of writing it to the screen like we're doing it here. Let's see, we had that originally in driver. So we had our file output stream. This guy. And a data output stream. Client. Rather than printing it out to the screen, we'll go ahead and have our file output stream. Data output stream. What happened? Oh, did I overwrite something that used to be there? Copy that. We're going to have those outside of the try. File output stream, FOS, data output stream, EOS. We'll read the byte from disk client. We'll get our file output stream, get our data output stream. When we're done reading in the file, file received, and then we will close our data output stream. Actually, do we need to close it? I think we saw before we didn't have to do it. Just throw an exception. Oh, it's just complaining it may not have been initialized because I initialized it. Just give it initial values. One, doesn't matter if I close the file output stream as opposed to the data output stream. Should be the underlying communication channel. And this is going to be called Cambria copy. Okay, so in the current thing, we should keep reading bytes, keep reading bytes, keep reading bytes as soon as we actually I could have built this up here rather than the null thing. So we're going to do a write byte B. So I'll keep receiving them, writing them over and over and over again until we finally get an EOF exception, and we'll say file is received. We'll say FOS closed. This thread should then die. But if we want, we can do like a system.exit 0. That would definitely kill off the thread. We've run out of stuff there. Okay. So back out here. I'll go ahead and clear this. As we have our server. Where's this guy live? Oh, it's in the client directory. Run this, get the server up and running. File this. Set up our receiver. Start this, set up our sender. That guy's done. This guy is done. We should have a Cambria copy in there. And let's see if it is the thing that we wanted it to be. Cambria copy. So technically, these don't need to be running on the same computer. They should be able to run anywhere in the world, with the exception that we need to put in the IP address of our server for it to connect. And you can have multiple receivers at the same time. So we can have 20 different connected clients all having this one file broadcast to it. All right. So that was some interesting twists and turns. Let me push that. Working, send, receive. All right, so questions about any of that stuff, like how we sent stuff, how we set it up as a single server, had two clients, well, had one client that picked a mode that was going to be in. Makes sense what we tried to do. How does this differ from BitTorrent? Based on, so for those of you who've used BitTorrent again, how does BitTorrent work? Go ahead. Yep. So how do the clients find out about each other initially though with BitTorrent? So a server has to be involved at some level, but it's not there for the communication. The servers effectively collect interested parties in a torrent and then connect them all to each other where, you know, when you turn on your BitTorrent client and you participate in one of the torrents, you are, you know, usually when you first start doing it, you're sending and receiving, right? And then when it's done, it's just in seed mode. So it's somebody who's willing to give data out there, but it's not pushing data, as you said, it's not pushing it to a server where the server is then broadcasting to other people. Instead, it's getting information about, it's getting a request for a specific byte. Let's keep it that granular. So we're going to have a collection of bytes from this guy. I didn't notice how many total bytes we had, but it wasn't like millions, right? Pretty small file. So let's call it a couple hundred bytes or something. So we're going to have an array of bytes that as we download the file, or the original guy has the file, you know, he's going to have this array of bytes, and other clients can, you know, if I'm a client who's trying to receive the file, I have this array and the array is initially completely empty. So I'm interested in any of the bytes, right? But as I start filling in that puzzle, there's only certain bytes that I'm missing. Does that make sense? That's why towards the end of a torrent, when you have a relatively small number of seeds, the speed slows way down, because sometimes you're asking for a byte that nobody else on the thing has because all the seeds have pulled out or something like that. Probably an oversimplification of how it's actually working, because I'm guessing there's some optimizations in there where you're, instead of receiving a single byte, you're probably asking for collections of bytes from the different clients. Otherwise, you can imagine for like a 2-hour movie or something like that, there'd be a lot of bytes you're trying to fill in the puzzle for. But roughly speaking, you're sharing bytes, you're requesting bytes. So what we need to do now is, in our next step, is we need to say, well, how do we get the clients to be aware of each other? Now, these guys have an IP address or whatever, but when a client connects and says, I want to participate in a particular torrent, the clients say, I'm either right now we're saying send or receive, and we're sending all our bytes currently through the server, then broadcast down to everybody else who's connecting. we want to convert this to peer-to-peer, where somebody who's sending, or BitTorrent words would be somebody who's seeding the file. They are willing to take requests for individual bytes, and when they get a request, they send that request directly to the client that asked for it, not through the server. So that means our clients need to have everybody who's seeding the file needs to have a way of getting their IP address and the port they're listening on locally, which for BitTorrent would be some sort of, solid port, whatever the BitTorrent seed port is. For us, since we're testing it on a single machine, we'll probably have to have our clients increment the port number, because one client's listening on 2222, the next one's on 2223, because we don't have different machines with that same whatever port 4000 open. Okay. So when somebody goes into seed mode, effectively they become a server that can now get requests from other clients. The information about their IP address and the port you talk to them on has to be broadcast somewhere. So when you first join a torrent, something that you get is a list of all, and you've seen it before when you go to something that shows, all the files that are currently available. It'll show you how many seeds, and what is it? I think it just gives seeds and what's the other word? I know there's leeches. What's the seeds are people broadcasting? I guess maybe it only says seeds. The higher the number of seeds, the more availability of bytes is likely going to be out there. So now our client also becomes a server because he's a server to other clients. So when a client connects, they are connecting and making the world aware of that they are here and available. All right. So we need to update this so that a client can go into server mode. I'm thinking, since we're doing this, do we just make our changes in here? Yeah, whatever. We have it on GitHub, so you can look at the historical things. So when a client connects, they're going to open up a connection to the server. So we would say this is like the BitTorrent service, because you got to have some point where this guy's job is to broadcast the IP addresses and ports of all the connected clients who are participating in this file. Right now we have some text input, blah, blah, blah. We're probably going to change it, instead of being a send and receive mode. Right off the bat, you're both modes. So if you've used BitTorrent before, right off the bat, typically you start downloading because you need to collect some bytes first, but then you become a seed thing where the more you've gotten downloaded, the more you're able to upload. So every client that connects is going to become both a sender and a receiver, but probably initially they'll be a receiver only until we hit some threshold where we say, okay, you're now a viable sender. So let's see, we have our initial socket. I don't think we actually need to have this back and forth blah. Yeah, I feel like we should just get rid of all that. There. It's our client now. It's like, so long, it just finally worked. We just deleted it. All right. So we'll make our initial connection to the server. Now, as we have it right now, there's this like back and forth talk between the server and the client. And we're saying, well, are you the sender or the receiver? And then we're sending it back. Behind the scenes, if we're just running the client, we don't need to see that chit chat. That chit chat doesn't even need to happen, right? The client can just assume, oh, I'm connected. I'm just going to send to the server what mode I want to be in, because the client knows knows about the server. We don't need to add extra crap in there. All right. So we're going to have a string. Call this guy torrent name. Call it Cambria.jpg. So we'll name our torrent name the same as our file name. That's how we'll keep these. So we'll have a hard-coded one initially, but so maybe the very first thing it sends is the torrent name that it wants to work with. So we need a output stream. So we'll say a print stream, text output over socket. So a new print stream built using s.get output stream. All right, so the very first thing we'll do is we'll go ahead and write the torrent name that we want to be part of. So we'll say text output over socket.println torrent name. Okay, now this guy, and actually let me do something so I don't forget, since it's on my mind right now. How do I create a new branch on here? So we'll call this guy torrent mode. Create that branch. Bring my changes to torrent mode. All right. So this way, when I push these updates, it'll be in a new branch on GitHub called torrent mode. So all the stuff we did earlier today will just be on main. So you'll have a working client server thing. Okay. So we're just going to send to the server. This is the torrent I want to participate in. Here's our server. All right. So we're doing text input, text output. Okay, so we're going to read in. So we'll say, get the torrent they want to participate. So we'll say torrent name is equal to my scanner. So this dot text input dot, was it next line? So that'll be my torrent name. All right. So with a torrent name, if a client is asking me information about a torrent name, what's my now responsibility to that client? Well, initially that client wants a list of all of the peers that are currently involved in that guy, right? Now, that list of peers, though, constantly changes, doesn't it? You're going to have some that drop off. You're going to have some that get added on. So there's going to be certain peers that you used to be able to ask for bits from or bytes from that have now disappeared. And you're going to have other ones that have been added to the list later on. So what is this? How are we going to accomplish this? How do we make sure that this connected client is constantly aware of his current state of peers that he can work with? Before we even think about sending bytes and requesting bytes, how does he just know who's playing the current game? So the server here, he potentially knows about all the connected clients. Every client who wants to participate in a particular torrent, the server becomes aware of all those clients. So we probably want to store that information somewhere, right? All right, so what information do we need to store for a client to make a connection to another client? IP address and port number. Having the open socket doesn't do us any good because we don't have any way of sending an open socket over an open socket. Make sense? So what we're going to need to have, what we're doing right now is effectively bypassing that problem by having our clients talk to each other by way of server. Make sense? So we're connecting the phone call up here. Go ahead.
So you send, so each client has access to the host name and the IP address, and you can create a socket to that.
Because the client also then becomes a server. So we're going to have multiple threads that spin up here. So every single time we have a client connecting to the server and they tell us, hey, I'm participating in this torrent name, we're going to have to get a couple of pieces of information from them. Like you said, we need to get IP address and we need to get port number. Since we for real BitTorrent, they wouldn't need to send port number because there's a set port number for BitTorrent for receiving. I'm presuming, but yeah, I'm guessing they would need to send it if you're able to change the default port number. If you can't change the default port number, then they wouldn't have to send it. But we're going to have to ask for both of those things. We're going to have to say, okay, so string IP address is equal to this dot text input dot next line. And then we'll read it as a we'll read it as a string. Port number. All right, so these are the three pieces of information. So if I'm on the client side, I'm going to send the torrent name that I want to deal with. I'm then going to send my IP address. So I'm just going to say IP address here for a second. And then text output over socket.println. Let's say port. All right, so a couple of issues we need to deal with here. Since we are going to be running and testing this on our own computer here, we probably need to have some way of keeping track of what ports have currently been used and which ones haven't. Because if we're going to, for instance, right now, we're going to have two different clients connect if we keep testing the way we've been testing. So those two clients are going to connect to the server and say, hey, I'm interested in this torrent. The server says, okay, I'm going to add you to the list of current participants. Each of those clients then says, okay, here's the information you're going to need for other clients to talk to me. Because I'm going to go ahead and spin up a thread that's going to become a server for those clients. Well, if we're testing from the same machine, they can't both say they're listening on port 3000. You can only have one server listening on port 3000. So we're going to have some sort of control mechanism for what's the next port number? Go ahead.
How many ports are there?
Usually it's 65,536, but it's possible they went up to 32 bits instead of 16 bits. That might be dated information. Typically the first 1,024 are reserved for system stuff. And then historically it's 65,000, 16 bits.
Is there any reason you're using like 232?
Something above 1,024 is user space ports. If you've ever run your own web server on your machine, like maybe in like the 460 class or something like that, a lot of times the default port is 8080 because the default HTTP, the normal web server port is 80. So 8080 kind of says, I'm a user web server and not the operating system's owned web server. Make sense? Yeah, but we're just picking them out of the sky. But we need to make sure that we pick unique port numbers. So if I want all of my clients, because we're testing locally, this would not be a problem if we were guaranteed to have all of our different clients on different machines. But because we're testing locally, and I want each of my clients to advertise themselves as, here's my IP address. Oh, and the port number that you can use to reach me is this. How would you go about making sure every single client has a unique port number? I mean, any way you cut it, it's going to kind of be a hack, but kind of based on the pattern we've been going through so far. The ideas, good.
You have a sticky note right there. You just write it down.
But we're going to be automating it. Go ahead.
Keep track of how many have been created and just do the socket number plus that number.
Okay. So somehow just having a running tool. Maybe put that in a singleton because all of our individual threads need to have access to it. Fine. Okay. So the sticky note is the singleton, right? And in there, we're going to have just a counter that says next port number. And we'll start with the starting one. We use port 3000. And the next time will be 3001, 3002, 3003, yada, yada, yada. That's what I thought he was going to suggest. It probably would work. It's a really low chance if you run a program and just create random numbers until you have a duplicate. It'll run for a while. I mean, the chances of us having two running clients with random port numbers that are equal, just astronomical. But just watch it would happen the first time we run it. I think I told you, at least in one of my classes, I probably told you this before, but this was must have been 15 years ago or something like that. I was doing a sample program in class where we were randomly generating words, just taking random letters between A and Z. Very first word that got generated was the F word on the screen. We didn't record back then, but what are the chances? What are the chances of that going down?
Are you doing 4-letter words?
We were doing 4-letter words. Well, I mean, but at that point, it's like funny, right? It's like, we're all adults, but it's like, what are the chances of that going down? And I think the whole rest of the time we were working with that program, we didn't get another real word. It's like, that was the opening ninja move, and everything else was downhill. Okay, so we need to figure out a couple of things. We'll go ahead and create a client. So inside of our client folder here, we don't have a singleton in here yet. I'm going to go ahead and call it client core, just so we don't get it confused with our thing up here. So we're going to call this guy client core .java. And inside of client core, we'll have a private static int next port. And maybe we'll start this off at port 3000. All our clients will start off with port 3000. And then we'll have a public static int get next port number. And I'll go ahead and actually synchronize this one. That way we don't accidentally hand out the same port number to more than one client. Even though I am incredibly fast reflexes, I switch from tab to tab. This is highly unlikely. So, but we'll still synchronize it. So we're going to go ahead and we're going to say, well, this would actually be a good example of a time when you can take advantage of that plus plus thing. So I could say I'm going to return next port plus plus. When I have the plus plus afterwards, what happens? What's this? What value is going to get returned here? What's the difference between plus plus next port and next port plus plus? We would have talked about this in probably 200. And I probably said, never do this. Makes nobody's impressed. Do it on 2 separate lines. Go ahead.
Does after actually modify the value at the pointer and before it just returns the.
At the end of the day, if you use plus plus, the value is going to change. The question is when does it change? If you have the plus plus before next port, it will increment it immediately, then return that updated value. If you have the plus plus afterwards, it's going to give me the current value of next port, then it will still increment it. So since I'm doing this all in a single return statement, I'm returning the current value of next port, and then kind of on its dying, on its deathbed, he increments the value on his way out, even though this is part of a return statement. So this might be kind of a reasonable use of the plus plus. Otherwise, you'd have to do something like next port plus plus like that, and then maybe return next port -1. And you're getting the previous next port, the old next port, because I made sure I updated it. So you can decide which one you like better. But this would be a decent use of the next port plus plus thingy. And that exact reason. So think about that. You've had, so most of you are at least juniors. So you've had 3 years of various computer science stuff, and this is a pretty trivial topic in the big scheme of things. Yet the advice of always put it on the same line is still safe, because you might not quite have it in your head yet what the difference is between plus plus something and something plus plus. They do behave differently. All right, so now we just have our client core. So we're going to send from this guy. Client core get next port number. So when we send our port number, we're going to do that. So what we'll have to figure out next time is how do we get our IP? I'll throw a little error in there. That way it'll zoom me into that line. All right, questions, comments, concerns, bribes. All right, I will see everybody next Tuesday. Remember, classes after 4 p.m. today do not meet. No class tomorrow, no class Monday. If you're traveling home for Easter, have a safe trip, and I'll see everybody next week.